So we really like our house. It's in a pretty ideal location. It's within walking distance of the downtown area where you have all your shops and various restaurants. It's got a big backyard and just plenty of room for us. The biggest issue that we have is that the driveway is so close to the road, and there's a surprising amount of traffic here in spite of the fact that there's only 11 houses on our street. And people tend to go pretty fast around here. There's a 30-mile-per-hour speed limit sign and a slow children at play sign, but no one seems to really pay attention to them. When we first moved into the house, we actually called the city engineer to see if they would install a speed bump to slow down the traffic. Unfortunately, at the end of our street is a rehab facility, and they have to keep the street clear for all ambulances and emergency personnel. All of this means that when our kids are playing outside in the front yard, we are genuinely concerned about their safety. And I've decided to take matters into my own hands a little bit and conduct a little experiment, and while doing so, raise a little neighborhood awareness. The plan will work like this. If this house represents our home, I'm going to set up 2 reference points in the front yard, and using this stopwatch, I'm going to be able to tell how fast the cars are going as they're passing each point. I decided to use my mailbox as one reference point, and then got Daniel to help me measure 50 feet out to put another pole in as another reference point. This point was in straight line of sight of the mailbox, and then I was able to observe both points from the comfort of my porch. Alright, so for this next part, we're going to have to use a little bit of algebra and physics. And we use the formula speed equals distance over time. But because my experiment is measuring feet per second and I need miles per hour, we're going to have to do a little bit of the conversion. And we're going to expand the speed formula, and we'll use 50 feet, which is the distance between our 2 reference points, and we'll use X seconds, which is the amount of time it's going to take a car to go between those 2 points. We'll multiply that by 60 seconds over 1 minute, 60 minutes over 1 hour, 1 mile over 5,280 feet. Seconds cancel, feet cancel, minutes cancel. Doing some quick math, that brings us to 180,000 miles over 5,280 hours, which then breaks down to 34.09 miles over X hours. Now, I could use a calculator for each one of these calculations, and I'm sure there's apps out there that will do this for me, but I just went ahead and opted to use an Excel sheet instead. I used a very basic Excel sheet and was able to recreate the formula and put it into a cell, which in turn allowed me to be able to put in the seconds and get the most accurate miles per hour data. I also included a time of day column, which was actually Ash's idea. I don't know why I didn't think about that. I also created an average column, and I'm going to use all of this data to judge the difference between a couple of the things that I'll explain here in a little bit. I like using this Excel sheet because it allows me to be able to input a lot of data at once. All right, now that everything is set up, it's time to do some data collection. Now that I created a pretty good control group for my experiment, I decided I needed to get one of those neon caution signs from Home Depot. So I've got my little research assistant out with me.
Hello.
Daniel has gotten me plenty of fluids as I'm sitting in the hot, or not even in the hot sun.
Hey, Dad.
Hey, what is that? He's getting me a pillow. Gosh. Thanks, pal. It's just the marked difference between Daniel and Charlotte. Daniel makes sure that I'm taken care of. Charlotte doesn't care. So for this data collection with the neon sign out front, I'm looking at 2 things, and that's one, the speed, just like I was with the control group, but I'm also looking at facial expressions to see if people seem to even notice whether or not there's this new neon sign out front. So I've gathered the information I need so far for that part of the experiment. Now I need to proceed to phase 3. Time to input the data. Okay, the whole purpose of what I was trying to do was to see what it would take to get someone to actually slow down in our neighborhood. And I basically had 3 different methods that I used. The first I considered my control, and that was just nothing at all. I didn't want anyone to see that I was actually trying to record them. So I basically assessed a very natural environment of people just going to and from on the road. The second thing I did was add just that little neon sign, which you see a lot of people will have in their neighborhoods. Honestly, I feel like it's so common that people just ignore it, and I feel like that's kind of the case with what happened here. And thirdly, I just went a little more extreme, and obviously I used my own signs, which were not true at all, but I was curious to see if people would actually take that and try to slow down. Now, the data shows that without any kind of signs, the average speed was 25.03 miles per hour. With just the neon sign, it was 21.3 miles per hour, and then with the signs that I created, the average was 18.84 miles per hour. Now, there's a lot of factors that go into why this could be different. We tried to gather all the data at the exact same time each day. Some of it was gathered on a weekend, and I know that kind of changes things. Some of it was pulled on a Friday afternoon, and I know that people were just trying to get home. There are a lot of factors that go into it, but based off of what I gathered, people did kind of seem to notice. What did surprise me is the fact that even without any signs up and people just going about their day, the average speed was just above 25 miles per hour, and the posted speed limit is 30 miles per hour. What I will say is of the approximately 12 residents that I observed pass by, only one of them was going over 30 miles per hour. And the people who were speeding or going over 30 miles per hour were generally employees of the rehab center or visitors to the rehab center. The other thing that was really interesting to note that Ashley and I did not realize is the amount of traffic on our road. I mean, there is no outlet. It dead ends at the rehab center. But on the first day of gathering data, we sat there for an hour and a half and over 40 cars passed by our house. Another trend that we noticed is it seemed to be repeat offenders. And generally those people who were speeding were either looking down at what appeared to be a phone or looking straight ahead and didn't even observe anything in their surroundings, which to me is a little bit concerning. And it would only take one instance for our kids to run into the street chasing a ball or something like that and someone not be paying attention, and that could be horrible. I understand why the speed limit is 30 miles per hour through our neighborhood, and that's because of the medical personnel, but I think it should be more like 25 miles per hour. I was looking at the speed calculator, and at 30 miles per hour, it takes 74 feet to stop. At 25 miles per hour, it takes 56 feet to stop. That difference in 18 feet, well, it could mean a lot. I guess the overall point is if you're gonna go through a neighborhood, please don't speed. I doubt that they'll change the speed limit here, and apparently the police officers sometimes patrol this area to try to catch speeders, but let's be honest, of the 40 people that are passing by in an hour and a half, a cop's not gonna catch them all. So maybe you should just do the right thing and slow down.